There's a moon in our solar system that looks like Earth, but it's minus 290 degrees. It has rain, rivers, storms, but not made of water. Scientists think it could even host life, but not as we know it. It's not Mars. It's not Europa. It's Titan. And what we've found there will blow your mind. Far beyond the warmth of the sun, deep in the cold reaches of the outer solar system, drifts a world that shouldn't exist. It rains here. There are lakes, rivers, even seasons. But this is no Earth. This is Titan, Saturn's largest moon, a place where rivers flow not with water but liquid methane, where the mountains are made of ice and the seas are darker than oil. With every flyby, every pixel of data, scientists have uncovered more of Titan's secrets, and what they've found is astonishing. Could this frozen moon hold the clues to life beyond Earth? Could it even be alive in its own alien way? Titan is Saturn's largest moon, so large it's bigger than the planet Mercury. If it orbited the Sun instead of Saturn, we might have called it a planet. But size is just the beginning. What truly sets Titan apart is its atmosphere, thick, rich, and completely alien. Titan is the only moon in the solar system with a dense atmosphere. In fact, it's thicker than Earth's. Composed mostly of nitrogen with a touch of methane, this orange veil hides a world few expected. Despite temperatures cold enough to freeze oxygen solid, Titan has lakes, rivers, even rain. But these aren't made of water. On Titan, methane and ethane, normally gases on Earth, flow freely across the surface, forming seas the size of continents. For decades, Titan was a blurry mystery, but thanks to NASA's Cassini spacecraft and the daring descent of the Huygens probe, that fog is lifting. And what we found is nothing short of breathtaking. On Titan, nothing behaves the way we expect. Its atmosphere is a dense blanket of nitrogen laced with methane and complex hydrocarbons. These gases, harmless and invisible on Earth, drive an alien version of our water cycle. Yes, Titan has weather. It rains, it storms. There are even seasons. But here, it's not water that flows. It's liquid methane and ethane. Imagine standing there as droplets of liquid gas fall from a pitch-black sky. The ground beneath your feet is rock solid, but it's made of water ice, frozen harder than granite. With surface temperatures at minus 179 degrees Celsius, even the air is surreal, so cold that water behaves like stone and methane flows like water. And beneath this frozen crust, scientists believe there may be a hidden ocean of liquid water tucked between layers of ice, a second world inside a moon. The chemistry of Titan is exotic, extreme, but also familiar, too familiar. Could this frozen chemistry set be more than just alien weather? Could it be something more alive? For centuries, Titan was little more than a fuzzy dot in the sky, a mystery veiled in clouds. But that changed. In 1997, a collaboration between NASA, ESA, and ASI, the Cassini-Huygens spacecraft set off on a 7-year journey to Saturn, a mission of ambition, a mission of patience, a mission of firsts. Cassini would become one of the most successful interplanetary missions in history, spending over 13 years orbiting Saturn, studying its rings, its storms, and its moons. But it was Titan that captured the imagination of scientists, and in 2005, something extraordinary happened. The Huygens probe, a small hardy lander, was released into the unknown. As it plunged through Titan's thick atmosphere, it became humanity's first ever landing on a world in the outer solar system. It fell for 2.5 hours, through clouds of methane, past alien winds, to a frozen surface no human had ever seen. What it saw shocked scientists. A riverbed, dry yet shaped by liquid, rounded ice pebbles smoothed by flowing methane, a surface that told a story of weather, of movement, of change. Titan was no longer a blur. It was a world, real, complex, dynamic, and just strange enough to remind us of home. Cassini would go on to make over 100 flybys of Titan. Using radar to peel back the clouds, it revealed vast methane lakes, towering dunes, and possible cryovolcanoes, ice volcanoes that might spew water instead of lava. From over 1 billion kilometers away, we reached out to a distant world. And for a brief moment, it reached back. In all the vastness of the solar system, Titan may be the place that most resembles Earth. There are rivers here, lakes, dunes that stretch across continents, clouds that drift across the sky, and rain that falls from them. Titan has its own version of the water cycle, but instead of water, it's methane that rains, flows, and evaporates. A mirror world, one step removed from our own. Titan's largest sea, Kraken Mare, covers more area than the Great Lakes combined. It's so vast, Cassini couldn't see across it. These seas may even have waves, tides, and possibly icy shores that crunch beneath toxic winds. It has mountains, carved not by tectonics, but by ancient cycles of erosion. Massive dune fields, hundreds of kilometers long, shaped by winds we still don't fully understand. And though Titan's skies are orange and its oceans are deadly cold, the geography is hauntingly familiar. It's as if nature, given a different set of ingredients, still followed the same recipe. Titan is a ghost of Earth, a world frozen in time, yet alive with movement. Titan is a world of paradoxes, familiar yet hostile, Earth-like yet lethal, and it raises one of the most provocative questions in all of science. Could life exist here? On Earth, life thrives in the most extreme places imaginable. Boiling acid springs, freezing deserts, the crushing depths of the ocean. If life can survive there, could it adapt to Titan's alien chemistry? But Titan is different. If life exists here, it wouldn't be like us. It wouldn't use water. It might not use oxygen. It might not even recognize DNA. Some scientists believe that Titan could host life based on liquid methane, a completely different biochemistry. Cells that use methane instead of water. Structures built not from carbon chains, but from molecules we barely understand. Others suggest that Titan's true secret may lie hidden beneath its crust, in a possible subsurface ocean of liquid water. Cassini detected wobbles in Titan's rotation, tiny, subtle shifts that suggest a slushy liquid interior, a warm ocean buried beneath a frozen sky. If life did emerge here, it would be silent, slow, alien beyond comprehension. But if even the faintest spark of biology exists on Titan, it would change everything. It would mean Earth is not unique, that life is not rare, that the universe is, perhaps, inevitably alive. For decades, Titan has whispered its secrets across the void. Now, we're going back. But this time, we're not just landing, we're flying. Dragonfly is unlike any mission ever attempted, a nuclear-powered 8-rotor drone designed to fly across Titan's vast and alien surface. Slated to launch in 2028 and arrive in 2034, Dragonfly will hop between locations, covering hundreds of kilometers, far more than any rover could. It will search for the building blocks of life, study Titan's chemistry, analyze its surface, measure seismic activity, and maybe, just maybe, catch a glimpse of something living. From the first blurry images in the 1980s to Huygens' brief descent in 2005, Titan has slowly come into focus. Now, Dragonfly may finally reveal its soul. No wheels, no tracks, just wings and courage, flying through an atmosphere 4 times denser than Earth's, in gravity barely stronger than the Moon's. It's not science fiction. It's happening. Humanity is building a flying laboratory for an alien world. And when Dragonfly arrives, it won't just show us what Titan is, it might show us what life could be. What makes a world alive? On Earth, life surrounds us, but how did it begin? And could the same spark ignite on a world like Titan? Scientists believe that life on Earth began in its oceans, complex molecules forming in warm, nutrient-rich pools. But Titan, too, is rich in organic chemistry, a frozen laboratory with its own ingredients, its own environment, and possibly its own solutions. High in Titan's sky, sunlight breaks apart methane molecules, triggering a cascade of chemistry that creates tholins, complex carbon-rich compounds that drift down to the surface like ash. These tholins could be the precursors to life, the building blocks, the same kinds of molecules that may have kick-started biology on Earth billions of years ago. Is Titan showing us a different version of the same story? A mirror of what Earth once was, or what another world could become? If Titan, cold and distant, can generate the ingredients of life, what does that say about the rest of the universe? Perhaps life isn't rare. Perhaps it's inevitable, not an accident, but a pattern. And if the spark of life can take hold on a frozen moon in the shadow of Saturn, where else might it be burning? Where else might life be hiding? In the cold, distant dark, Titan waits. A frozen world with a liquid heart, whispering secrets we've only just begun to hear. So, over the next few years, hopefully we'll unlock Titan's secrets. Until then, keep looking up. Thanks for watching. You've made it this far, so give the video a like, it really helps out, and subscribe if you want to see more fascinating deep dives into space,